Hello, assalamu alaikum everyone. I hope you are all fine. So today's lecture is about the working of OSPF protocol, and we will discuss the working of OSPF protocol through an example, and we will discuss how the OSPF protocol will work in a typical network. So let's quickly see the basics of OSPF before going through an example. OSPF works is based on a link state algorithm known as to be a digestra, and the cost for computing the minimum in order to compute the minimum cost, the cost is considered to be as bandwidth, whereas we have seen in the RIP the cost is the minimum hop count, whereas in this case the OSPF computed the best path based on the maximum bandwidth. So if you are using the Cisco router, the Cisco uses a default cost of 10 to the power 8 bandwidth, the default bandwidth of the interface using the bandwidth command, and this is set to be as the reference bandwidth, and it is used to this is used so that the faster links have the lower cost. So the more faster the link is will be, the lesser the cost it will have. So we will choose that link which has a lesser cost, and the lesser cost means the higher the bandwidth. So the routing matrix is lower the cost the better the route. In case of OSPF, the lower cost means the higher bandwidth. So the reference bandwidth can be modified. Yes, this 10 to the power 8 bandwidth can be modified to accommodate the networks with the links faster than 100 megabit per second, and this can be done using the command of OSPF auto cost reference bandwidth. We won't be discussing that. So let's see how the link state concepts are being applied in a OSPF routing protocol. First step in order to compute the best path is to flood the link state information, because firstly no router will be knowing about the cost of the other connecting routers. So in first stage we will flood the link state information. For example, the router A will send that, hi, I am router A and I can reach router B through this link, and I can reach router C through this link, and each router will send this announcement for all the routers in the network. So it will be flooded, and it's a broadcast. So next step in order to compute the best path is building a topological database. So now announcement has been done. Now each router collects all the link state information from other routers and puts into a topological database. You can see in this example, in this diagram as well. So the topological database is been constructed based on the received information from the other neighboring routers. And third step is to determine the shortest path using the digestor algorithm, and we will apply the digestor algorithm after basically building the topological database. And we have discussed the working of digestra as well in the previous lectures. You can see the videos of the digestra as well, which I have given explained the concept of digestra through the examples. A fourth step is to find the shortest path tree. After the calculation of digestor algorithm, the shortest path tree is created with the router making itself the root of the tree, and the other routers and links to choose the routers, the various branches. And last step is to make the routing table based on the shortest path first tree, and this routing table will be used to forward the packets onto the network. So let's see through an example. Here you can see router A. This is your starting point. Router A is connected to 3 other routers, B, C and D. and your starting point is A. So your source router is A, and I have discussed that OSPF is, if we take the reference of an hierarchical routing, then OSPF is a routing protocol which works within the autonomous system. So OSPF will work within the area or within the autonomous system. So all the routers will flood their link state information. So let's see, A will be connecting to other area router as well, and this is the leaf basically, which has been assigned an IP address of this, and it has a cost of 2. So A will say that I am connected to B uh, with the cost of 15, and this cost means lesser bandwidth. Okay, higher the cost is, the lesser the bandwidth. Lower the cost is, higher the bandwidth is. So it will say that I am connected to B via interface this, which has an IP address of 11 point something, and it has a cost of 15. And I am connected to C, which has a cost of 2 using the IP address of this, and similar to D. And I have a leaf of this cost and this IP address as well. So it will broadcast this information to all the other routers. So now see how next router is to be B. We will find the next information from B. Now B will get the information from connected router A and from the other connected router E, which has been directly connected, and it will say that I have a leaf of this as well. So this information will be received to A, and now A will attach his graph to the B's graph as well. So the resulting graph, this was the graph of A, and this is the graph of B, which B has sent the information to A. And A now basically joins these two graphs, and the resulting graph is something like this. So now let's say C will broadcast its information to A, and now A will say, C will say that I am connected to A using this interface IP address, and I have a cost of this, and I'm connected to D as well with a cost of this, and I have a leaf of this. And now A will do that it has computed the graph with B. Now it will result the resulted graph with B now will be added to the graph of C as well. So your resulting graph is now computing onwards. And next step is that it receives the information from D as well, so it will attach its graph to D as well, and now at the end it will receive the graph from E and information from E as well, and now attaches the graph with E as well, and the resulting graph is something like that. So your topological database will be computed from this topology we have received, and the next step is to find the best path to each node and leaf in the network. So how let's simplify how this topological data graph will be database will be computed. Now let's simplify this received and link state information, that at router B, basically this is the topological database for A. It will say that router B is connected to A using this IP address with the cost of this, and B is connected to E, and so on to E as well. So we will use this link state information for each router, and router A will run digester algorithm to create a shortest path tree. And that is now this is our resulting tree, and now we will apply the digester algorithm here, and the source is A and the destination is E, and it will compute the shortest path between A to E, and it has discovered that I am connected to these leaves and nodes, and now it will compute the shortest path based on the lesser cost. The lesser the cost is, the higher the bandwidth is. So we will be using the cost matrix to be bandwidth. the lesser the cost means the higher the bandwidth is. So uh, the resulting output is from the register is something like that, that this is your shortest path 3, that if you are going to we have selected firstly 2, then D, then E, and then at the end B as well. So the register works on the all path. So the resulting shortest path 3 will be put into the routing table. So this is your resulting routing table, that the interface number IP 10.0.0 is connected to E interface, and these are the interfaces of A router basically. 11.0.0, this is the interface and it is connected to serial port 0, and 12.0.0 is the router A interface S1, and 13.0 is the router interface S2. So the routing table is computed at A to be something like that. If you want your destination to be 14.0, which means your destination is this, so you will be having a cost of 15 plus 2, that is 17, and your interface A will send the packet onto S0. And if your destination is 15.0, which means this, so your cost will be 15 plus 2, 17, and your interface will be sending through your interface will be sending something like this from S1. So it means 2 plus 2, 4, 10, and then this one as well. So and for other interfaces as well. So that's how the OSPF will work. And the advantages of OSPF are that it is a link state routing protocol. The other routing protocols we have discussed are to be the distance vector routing protocol, which are susceptible to routing loops, split horizon, and there are various other issues as well. The RIP has a very slow convergence, whereas as compared to OSPF, which has a faster convergence, because RIP has a timer of 30 seconds, 180 seconds, and then 240 seconds as well. That's why RIP converges very slow. However, OSPF converges very fastly, and also RIP doesn't support the variable length subnet mask and the CIDR notation, whereas OSPF support both variable length subnet mask and CIDR. And the Cisco OSPF metric is based on bandwidth, which is a much more appropriate criteria to evaluate or to choose the best path among the available links. So whereas the RIP is concerned, it is based on the minimum hop count. EIGRP and IGRP also based on computed metrics to be bandwidth, delay, reliability, load. Yes, they can have something like that, whereas OSPF metric is simply on the bandwidth. And in this case, OSPF case, the lesser the cost means the higher the bandwidth is. So OSPF sends out the changes in the network whenever they occur, and whereas RIP sends the routing table after every 30 seconds, IGRP sends after 90 seconds, and the OSPF only send triggered updates when it comes. So the number of packets won't be higher as compared to the RIP protocol, and also the IGRP protocol in OSPF. So the link bandwidth utilization will be lesser, and the chances of congestion will be lesser in OSPF. So with OSPF, our router does floods its own table after it reaches the age of 30 minutes. Yes, it can, but it is a higher time as compared to the RIP. OSPF also uses the concept of areas to implement the hierarchical routing as well. And there are two open standards protocols to we can choose. First one is RIP, which is very simple, but it has a very limited functionality, whereas OSPF, it is very robust and it has some more complexity level as compared to the RIP, but it's more robust. So OSPF have some advantages over RIP. So that's all for today. Hopefully you will look this video and other videos of my channel as well. Allah Hafiz.